Welcome back to Outward Home Learning. The subject is computer science and the topic that you're looking at today is maintainability. So for this we're going to go over to Mr. Holton in a second, who's going to explain how maintainability works and some of the key things that you can do to make code maintainable. So over to Mr. Holton.
You are probably very used to developing code by yourself. It's probably how you've been learning. So you've created code by yourself. You might have tried to solve a problem with a bit of code and then you've saved it somewhere and never looked at it again. So you've not really come across this concept of maintainability and really understood how important it is. So let me try to explain that to you now. Any computer program that you can care to think of, really, which is in popular use, is not developed by one person. It is not developed by a single person sat at a computer tapping away and then they release it and they never have to change the code which is there. It is usually developed by a massive team of people. Now, when I say massive, it can be massive. Sometimes you get development teams of 2 or 3. Sometimes you get tens, sometimes you get hundreds, sometimes you get thousands of people working on code. Now, because of that, it means that any code that you write needs to be able to be understood by somebody else. So can this person over here understand your code? Can they understand what you've written, what you were trying to do when you were writing it? If you've made some sort of error, some sort of mistake, which happens all the time to the best programmers in the world, can this guy come and fix it? Because if he can't, then you've got a big problem. Your code has got a bug in it and it just can't be fixed, so it might not be usable. So maintainability is so important. They often say actually that you should treat writing your code as if the next person who's going to come across and read it is an axe-wielding maniac who knows your address. And that's not a bad thing to bear in mind. So let's just sort of cover how we can prevent perhaps being murdered by an axe-wielding maniac who's angry with your code. Have a look at this on the right-hand side. This code's not maintainable. It's horrible. And let's go through a few things that we can do to make it more maintainable. First thing, comments. If I add some comments into my code, I can instantly make it much more readable. Somebody can understand exactly what that code's meant to do. Because I'm going to guess, looking at it, you can't understand what it's meant to do. You'd have to take a very lucky guess if you did. Other thing, indentation. So all this code is the same distance away from the side of the screen. So here, this is the same distance away here, that if statement, then the next line is here, print. Let me show you what some code looks like with comments and indentation is, and we can see immediately it's much easier to read. So have a look here, comments here. This line here has got some comments in it, doesn't it? So this code checks to see if a triangle is an isosceles triangle by checking if two sides are equal in length. Immediately you know what that code does. Next thing, indentation. Look how far away some of this code is from the edge of the screen. This code here is further away from the edge of the screen than, and I'm going to go across that arrow there, than this code up here, than this while loop up here, yeah? Than this code. The reason for that is because the code at the bottom, like the len1, len2 bit, runs within the while loop. And if I use indentation cleverly, I can make my code very easy to read. I can understand what code belongs to which while loop and which code belongs within a particular if statement as well, like this print statement. So using indentation makes your code much more readable as well. Let's move on to a couple more things that you can do to make your code much more maintainable. First off, have a look at this code on the right. It shows a couple of key features. First thing is this here. I want you to have a look at this num questions asked. Can you figure out, do you think, just purely from the name, what that variable holds? Is it perhaps the number of questions asked? Well, yes, it is. So I can do that because of two things. First off, let's just deal with a problem. I cannot call my variable names this. I cannot call it that because I can't have spaces in variable names, but we want very descriptive, sensible variable names. So one thing we can do is put an underscore in between each of the words, and then that gives us, allows us to name variables in a sensible way. So number of questions asked, for example. That is called, using underscored, snake case, okay? That is a naming convention that is commonly used, snake case. Another naming convention, which is also very popular, if I had the same variable here, it would be num questions asked. And the idea there is that any new word begins with a capital letter apart from the first one. That is called camel case. Both of them are naming conventions, and if you stick to one, and it really does you have to stick to one for this to work, then your code again becomes a lot more readable, because you can have nice long variable names where it's very clear what data goes into what, and so because of that you can easily read your code and figure out what might be going right or wrong with it. Last thing as well, you'll notice this code has been split into subprograms. So there's a subprogram here and there's a subprogram here. Okay, subprograms are brilliant for various different things. First off, actually, this is an example. I can name them sensibly, so I can say this subprogram here obviously checks to see if the quiz is finished, and this subprogram at the top checks moves the quiz to a quiz to the next question. So you can name them sensibly so you can figure out what's going on, but also I can have a small part of code which is very easy to test. Okay, and if I do that, if I make my code up of loads of small parts which are easy to test, then if something goes wrong, so for example, my quiz is not moving to the next question, I know exactly where to look. It's in this subprogram up here, because that whole subprogram deals with moving to the next question. So splitting your code up into small programs makes your life a lot easier as well. The alternative, have a look at that. Have a look at that on the left-hand side and see you can figure out where the bug is. Good luck to you. If you don't have any subprograms in it, in your code, it can be very complicated indeed. So maintainability then. Subprograms, sensible naming conventions, using comments, and also making sure that your code is indented. If you do that, you will hopefully avoid that axe-wielding maniac.
For your first task, this is going to be self-marking. So you need to open up the Google Sheets document, and you need to identify some different types of ways that you can make code maintainable. So this is self-marking, so that we won't go through this after you've completed the task, but you'll be able to see exactly how well you've done. You've got 10 minutes, off you go. So that is your time up. What I recommend you do, if there's any aspects that you didn't get completely right, is I recommend you re-watch Mr. Holton's video a few seconds into this video, and then go back and re-answer those if you need to. But because that was self-marking, we're now going to move on to your second task of this lesson. So for this task, as ever, we're going to go over and do some exam practice questions. So if you want to open up the exam practice questions, you're going to get 10 minutes to answer these using your newfound knowledge on maintainability. 10 minutes, off you go. And that is time up. So now we're going to go over to Mr. Barnes to review those answers for us.
Okay, so let's have a look at this exam question around maintainability now you've completed the maintainability task. So it says the area of a circle is calculated using the formula pi times r squared, where pi is equal to 3.142 and r is the radius. A program is written to allow the user to enter the radius of a circle as a whole number between 1 and 30, then calculate the output of the area of the circle. Explain, using examples from the program above, 2 ways to improve the maintainability of the program. Okay, so we've got some code here. Alright, and we need to think, how would it be easier for someone to follow what's going on with this? Now, looking at this and being a Python programmer, I would say one of the obvious things that's missing here is indentation. Okay, so I'm going to write indentation would make it easier to follow the flow of the program. This would be used for the if statement. Okay, so I've made one identification of how we can improve the maintainability and also given the example in that program. So then we need a second one. Okay, so for example, I think it would be easier for me to understand what was going on if someone had added comments. So I'm going to put comments to be added to make it easier to understand. And I'm going to say for example, explaining the if statement checks that a number between 1 and 30 is entered. Okay, so there's my answers. So now let's get the mark scheme and have a little look. I'm just going to move this up so I can get it all on screen. Okay, so here we've got an EG answer, which means there are other appropriate answers, okay, but that's at the discretion of the marker. So the first one we've got here is indentation. So here in the mark scheme we've got indentation for a mark, and it says e.g. indenting within the if statement. So I said it make it easy to follow the flow of the program. This would be used for the if statement. Perfect. And then the second one, I've said comments or annotations. So comments to be added to make it easy to understand. For example, explaining the if statement checks a number between 1 and 30 is entered. So it says here, any relevant example, such as line 4 checks the input is valid. So I've done that, and I've got 4 marks.
And that's everything you need to know about maintainability. Stay tuned for the next lesson.